This is the calculus group project by Tiffany, Sunny, and Ryan. Question 1. In figure 3.1, the data is represented in the first derivative w prime of t. W prime of t represents the fetal slash placental weight as a function of time. The graph is showing the rate of change for both the fetus and the placenta's daily weight rate as time increases. This is figure 1. The graph above shows the relationship of the rate of the fetus weight in gram per day as time increases. And there you see the equation for this graph. Moving on. Figure 2. The graph above shows a relationship of the rate of the placenta weight in grams per day as time goes by. And there you see the equation for this graph. Moving on to question 3. Upon fitting a linear polynomial of degree 1 to each sets of data, the r-squared values proved that the linear fit was not a good one. The r-squared value for figure 1 with a linear fit was r-squared equals 0.2996. The r-squared value for figure 2 with a linear fit was r-squared equals 0.1064. We can conclude that this linear fit was not a good one, based on the r-squared values for both charts not being close to 1. Question 4. After fitting a polynomial of the fourth degree to each graph, it is evident that this is in fact a better fit based on the r-squared values being much closer to 1. The r-squared value for figure 1 is r-squared equals 0.7211, and for figure 2 the value is r-squared equals 0.81189. Figure 3. This graph represents a second derivative, and there you see the equation of this graph. Figure 4. This is the change over time of the rate of change of the placental weight. This is the second derivative of the first graph, and there you see the equation of this graph. Question 5 continued. The inflection points in figure 3 were at day 88, day 291, and day 448, where w double prime of t was equal to 0. This was confirmed by looking at the relative minimum and maximum values in the first derivative w prime of t, shown in figure 1. For figure 4, the inflection points were found at days 132, 197, and 251. In figure 2, these are the values of the relative minimum and maximum values in the first derivative, w prime of p of t, which confirms the inflection points values in figure 4. The inflection point in figure 3 represents the change in the rate of fetal growth. At day 88, the rate of growth of the fetus begins to increase. The growth rate begins to increase as it gets closer to its birth. At day 291, which represents the birth of the fetus, the rate is 0 as the fetus stops growing in utero. The fetus continues to grow right after, but at a decreasing rate. But then around day 448, the rate of growth of the infant begins to increase once again. Similarly, in the placental growth rate, the inflection points represent times of increase in growth rate and a decrease in growth rate. The inflection points for placental growth rate was days 132, 195, and 251.
The inflection points of the placental weight are occurring around similar time frames as the inflection points for the fetal growth weight. This indicates to be that one may be dependent or influenced by the other. For instance, as the placental growth rate begins to decrease, the growth rate of the fetus in utero also begins to decrease around the same time. This occurs in both around the time of birth. Question 7. The graph here is figure 5, which is the change in fetal weight over time, W of t, and down there is the equation that it belongs to. This is also part of question 7. Figure 6 is this graph right here, which is a change in placental weight over time, W of t, and there's the equation on the bottom. Figure 7, which also belongs to question 7, is change in placenta volume over time. And down there again is the equation, and up on top is the graph that it belongs to. Question 8. The placental volume at t equals 0, Vp of 0 equals negative 0.00007299 t to the fourth power plus 0.0007035541 t to the third minus 0.24787632778 t squared plus 39.32753408858 t minus 2119.875631286 would be approximately negative 2119.88 milliliters. This value does not make sense since volume cannot be a negative number. This data given starts at week 20, therefore does not prove to be useful in exploiting values beyond the scope of its range. The volume at t equals 0 is outside the range of this data and cannot be accurately calculated using this data. In order to measure the inflection point of the data from figure 7, the first and second derivative would need to be derived. Specifically, the second derivative would highlight the values of the data which are the inflection points. V prime of t equals negative 0.00000873 t squared plus 0.0042213 t minus 0.4957525. Once you solve the second derivative of the equation, you must set it equal to 0. Through this process, the inflection point of the placental volume is 593.248 when t equals 42 weeks. The same steps were applied to find the inflection point of the Forbes data, except we only had to take the derivative once, being that we started with the first derivative. You cannot compare the data directly since we are measuring two different things, volume versus weight of the placenta. The weight of the placenta was how heavy the placenta is during a specific time, while the volume of the placenta was how much space the placenta takes up as time goes by. Question 10. Comparing the placental volumes inflection point to the placental weight for Forbes data, it does not match the same time period. When converting the 42 weeks into days, it matches up the weeks presented on the graph. Since the inflection points match the ones on Forbes data, it shows the data in both experiments were valid and somewhat accurate. The inflection points occur at different times for fetal weight. The placental weight, because during birth the fetus is the first to halt its weight as it's getting ready for birth. Then right after would be the placenta, since it is completed and no longer needed inside the uterus. The data shown in the volume of the placenta complements the data of the placental weight in the Forbes graph, showing the same peak around 45 to 50 weeks. However, the placental volume data cannot be changed because of how different units of measurement of time. There are many medical reasons as to why they differ. One, for example, would be that the baby may have been birthed earlier or later than their due date, which is an impact on both weight of the fetus and placenta. Another example would be due to a birth defect with the baby that could affect the weight. One, Forbes collected the data they used an average of the fetuses to collecting, showing that no baby is exactly the same as another, which influences our results.